A video analyst spends a lot of time watching videos, scrubbing through videos, going backwards through videos, and pausing videos. It is time-consuming work and is often quite boring. The analyst spends time counting events and sometimes just figuring out what to do. In this video, we introduce slit-tear visualizations, which allow analysts to specify pixel paths of interest, tears, and to see what happens across these tears over the course of the video. To see how slit tears work, let's use a video clip I made by hanging a webcam out of my lab window. What you see here is a pedestrian intersection between several buildings. When we create a slit tear on the original video like so, a timeline visualization is created that shows what happens under that slit tear over the course of the entire video. We can use a timeline scrubber on the visualization to scrub through the video like so, and in this case we see all the people that pass through in a 3-minute period. When we get creative with slit tears, we can also use them to see patterns of movement through the video space. In this case, each streak on the timeline represents a different person passing through, and the direction of the streak tells us which direction they were going. Let's say you wanted to know how many cars pass through this intersection. Counting by watching the entire video would be time-consuming, or worse, you might miss a car if you dozed off. Instead, you could use slit tears. Drawing one across the crosswalk, the visualization immediately shows intrusions in the static 2D timeline. These intrusions, of course, are cars. There are 6 cars here that you can just count in this static visual summary. Now let's say you wanted to see how many cars pass through the other side of the intersection. In that case, you draw a second slit tear on the scene. Now you can immediately see that there were 5 such cars passing through the other side of the intersection. Finally, let's suppose you wanted to see how many cars go east-west compared to north-south. A third slit tear shows you that only 1 car passes east-west, but that a lot of people walk through the street going east-west. This is a video clip of an oval running track. In the foreground here you can see a kid running with his dad and some other people running through. In the background, if you look carefully, there are some people that pass through on the other side of the oval track. Let's say you want to be notified of when this happens. If you were to zoom in and do a scribbly slit tear kind of like this one, you can actually see when this happens. The scribbly slit tear replicates pixels in the timeline, and so when events occur, they immediately draw your attention to them. Here, each of the white zigzaggy lines represents a person passing through that slit tear. So here's one, and here's another. Beyond simple events, slit tears also do a very good job of making patterns and rhythms very obvious. So for example, when we take a look at the pattern of people's legs, they reveal a very nice, sort of beautiful pattern across the slit tear. This happens because there is a very regular period or recurring pattern when it comes to walking rhythm. So here you see the grandmother walking across the track, and we're just going to see it one more time and compare that against the runner that passes through the track. And you'll see that the slope of that pattern is much more steep because the runner passes through the slit tear far more quickly. I want to show you another video of an intersection, but this time from a side view. Drawing a slit tear allows us to see the cars as they pass through this intersection. Something neat that happens is that the visualization can show you, to some extent, how quickly the cars are passing through the intersection. The more squished they appear to be horizontally, the faster they were going through the intersection. Conversely, you can see a limousine-like black car here, and that one just looks that way because it's waiting to make a left turn. Now, if we draw 2 slit tears, one diagonally, we can see that the cars become slanted. Now, this looks kind of funny, but also serves another purpose. You can see that the direction that they're slanted also shows you which direction they were moving in the video. Cars slanted backwards are cars whose wheels went through the tear first before the roof. These were moving right to left, and conversely, cars slanted forward are cars going left to right. Again, you can see our limousine. Now the neat thing is that if you take this idea to the extreme, you can just draw a horizontal slit tear. Now you've got something that again looks quite neat. And again, the direction or slant of the streak tells you which way the car was going. But now you can also add a second slit tear that acts as kind of an index to the visualization, so you know which car created which streak. Finally, we've already seen that it's possible to compare different parts of a video to see if they're related to each other, but let's just do it again. Here's a webcam grab of some tough guy working an office job. We can draw a slit tear on his keyboard to see when he uses the keyboard, and another slit tear here to see when he uses his mouse. You can see that the mouse cord, unsurprisingly, seems to move a lot when his hands aren't on the keyboard, and vice versa, when his hands are on the keyboard, the mouse cord doesn't move a lot. And then just for fun, let's draw a slit tear on the Donald Duck bobblehead doll here in the back. And here we see that the periodic action of the bobblehead doesn't seem to have much effect on the mouse or keyboard events.